few worked out problems on normals of the parabola. So the first one, if two of the normals of the parabola y square equal to 4x are 4x plus y is equal to 72 and 3x minus y is equal to 33, prove that its third normal is y is equal to x minus 3. So of the of the three normals, two are given. We are asked to find the third one. So for this, we are going to consider the equation of the normal at P of T1. We will take the three normals to be say P of T1 and Q of T2 and say R of T3. Another one we want to have, so that is, let us take that as say some R of T3. The equation of the normal at P of T1 is this: y plus xt. At t it is given by y plus xt is equal to 2at plus at cube. So we consider here the point P of T1, so we have the equation of the normal at T1 to be this. Now the equation of the normal at T2 is given by this. Now we are going to identify equation 1 and 2 with the given equations, namely 4x plus y is equal to 72 and the other one. So when we compare these two, or rather identify these two, we conclude that T1 is equal to 4 and T2 is equal to 3. But we know that the relation among this T1, T2, T3 is T1 plus T2 plus T3. Sum of the ordinates is 0, from which we had this T1 plus T2 plus T3 equal to 0, or rather from the relation between the roots and coefficients. Once we consider this equation, three roots are there. Sum of the roots, because there is no t square term, we get 0. So of the 3 we know 2, so substituting that we have T3 to be equal to minus 1. Therefore the equation of the normal at T3 is equal to 1 is, we know already the equation of the normal at T3, so we have this, and in that we are going to just replace our T3 by 1. So we have y is equal to, see in this we shall identify our this one and this. So when we identify that, what is that we get? Here it is 1 by minus 1, and we are taking this to the other side. So minus 2 T2 by minus 3 equal to one more. We are satisfied with this itself, so we have T2 to be equal to minus 3. So our T2 is not 3, it is T2 is equal to minus 3. T2 is equal to minus 3. So substituting that here, we get 4 minus 3 plus T3 equal to 0. So T3 plus 1 equal to 0, and therefore T3 equal to minus 1. So the equation of the normal at T3 is equal to minus 1 is, we are going to just replace T3 by minus 1. So y is equal to x, and this is minus 2a. இந்த இடத்துல a வந்து 1. So you have just minus 2 plus again a வந்து 1. So T3 is minus 1. So you have minus 1 minus 2 already. So you get minus 3. So just T3 is equal to minus 1 here, and a in this case, because we are given the equation of the parabola to be y square is equal to 4, instead of 4ax you have 4x. So that tells us that a is equal to 1. Now coming to the second one, if the normal to the parabola y square equal to 4ax drawn at a comma 2a meets the parabola again at the point at square 2at, then show that it is equal to minus 3 if the normal to the parabola drawn at. So let t be the given point a comma 2a. So in general, we know that it is given by at square 2at. But that point we are considering here as a to a. So which means we can have that t to be 1. Okay, so instead of considering because t is already coming here, just to differentiate, we consider at prime square to at prime. So that point is taken in this way. So that tells us that our t prime is 1. Now we consider the normal at t, normal at t prime meeting the parabola at the point t. Then we know that, see, whenever we have a parabola and the normal at t1 meets the parabola at t2, means the relation between these two is t2 is equal to minus t1 minus 2 by t1. So here we have the normal at t, the normal at t prime meets the curve at t. So that means t is given by minus t prime minus 2 by t prime. So that is what is written here, and already we have computed our t prime to be 1. So you just substitute, you get t to be minus 3, and that is what we are asked to show. Then show that it is equal to minus 3. It is equal to minus 3 means that parameter. See, whenever we consider p of t, by that we mean at square to at. So here that parameter is taking the value minus 3. Now the third one, if a normal chord of the parabola y square equal to 4x subtends a right angle at the vertex, show that its slope is plus or minus root 2. So we are having a parabola and we consider normal at any point, say t1. Okay, and then if the normal subtends a right angle at the vertex. Now if a normal chord we are given, okay, if a normal chord, so let it meet. So normal chord is given, so it will meet the curve again at the point, say t2. Okay, then slope of this condition is given, that is this chord subtends a right angle, this chord subtends a right angle at the vertex. So then we'll have to show that the slope of this line, the slope of this, if we consider that to be say m, we have to show that the slope is plus or minus root 2. Okay, either plus root 2 or minus root 2. So that is what we are trying to prove. So you consider the normal at the point p of t1, which meets the curve again at q of t2. Then we have the relation t2 is equal to minus t1 minus 2 by t1. Now PQ subtends a right angle at the vertex. So we know that the slope of OP, this is at1 square to at1, and that is 0, 0. So difference between y coordinates divided by difference between x coordinates. So this is what we get. We can cancel one a, we can cancel one t1. So we are left with 2 by t1. So for this the slope is 2 by t1, and the same way for this it is 2 by t2. So that is equal to minus 1. The reason is these two are at right angles. So product of their slopes should be minus 1, and that in turn gives us that t1 t2 is equal to minus 4. Now this in turn implies that our t1 square is 2. So where from that we are getting, if we multiply this by t1, we have this relation. So in this, if I multiply throughout by t1, this is what we get. This t1 and this t1 will get cancelled. So but this t1 t2 is equal to minus 4. So you get minus 4 is equal to minus t1 square minus 2. Or in other words, you get t1 square, okay, minus t1 square, you get it as minus 2, or t1 square is 2. So that is how we are getting t1 square as 2. So from that we are getting t1 to be plus or minus root t. Now our job is to show that the slope of the normal is this. We know that the equation of the normal is given by y plus xt is equal to 2at plus at cube at the point t. So here we consider the point to be t1. So this is what we get. So then what is the slope? Y is equal to, rewriting this, you get y is equal to mx plus c. We are not bothered about this. So the slope is minus t1. For what? For the normal. So minus t1 is the normal, and the value for t1 here you are getting plus or minus root 2. So the slope is minus or plus 2, or simply write plus or minus root 2. So the next one, show that the centroid of the triangle formed by the feet of the normals to a parabola lies on the axis of the parabola. So we have P of T1, Q of T2, R of T3 to be the feet of the normals to the parabola y square equal to 4ax. We have to show that the centroid of the triangle formed by PQR2 y square equal to 4ax lies on the axis. So for that it is enough we show that the ordinate of G is 0. We are not bothered about the x coordinate because we want to have that centroid to lie on the axis of the parabola. So axis of the parabola means you have y is equal to 0. So if I am able to show that the ordinate, that is the y coordinate, you have something as the x coordinate. So if I am able to have the y coordinate to be 0, then what is required we will have. So the ordinate of G, we know that the centroid is given by 81 square plus 82 square plus 83 square divided by 3, and that's x coordinate. Y coordinate is, that is ordinate of G is 281 plus 282 plus 283 by 3. So taking this 2a by 3 out, we get T1 plus T2 plus T3, that is 0. So you have ordinate of G to be 0, and hence the centroid lies on the axis.